All right, down to the final question on the practice test. And it's a sort of a synthesis type question. So you're given very little support on this type of question. Right? All you're given is a few words. You're going to have to figure out, oh, these are the reactants. Okay. Therefore, based on how those reactants are arranged, I think it's this type of reaction. Okay, which means I'm going to produce these products. You got to write the correct formulas for the reactants, and then write the correct formulas for the products. And then once you've done all that, you do that final step of balancing. So this question, if you could just do this, I could probably grade number 9 and forget the rest of the test, right? Because if you can do all this, you can do everything else that appears on this test, all right? But I do have those other questions in there, just in case you have trouble starting this type. You're not limited in showing that you do have some knowledge. But that being said, let's dig in. First one, we got potassium metal. So I'm just going to go ahead and write my reactants first down here where it says balanced chemical equation. So potassium metal looks like that. All right, and we're going to add that to aqueous aluminum nitrate. So this is Al. That's plus 3, nitrate, NO3 minus, which means it's going to look like this, Al, parentheses, NO3, 3. And again, if you don't know why I wrote that formula that way, go back and review ionic compounds with polyatomic ions. All right, so I got my reactants. It looks like an A plus BC combo here. All right, so that tells me that this is single replacement. Okay, which means my cations are going to swap places. Potassium and aluminum will swap. Now, potassium being a 1 plus, right, will replace aluminum. But when I write the formula, it's just going to be KNO3. And again, remember that 3 there is part of the nitrate compound, so 3 stays. But I don't need that extra subscript because potassium is a plus 1, aluminum is a plus 3, which is why I need 3 nitrates to balance that charge out. All right, and then I'm going to be left with aluminum metal all by its lonesome. Okay, so a little partner swap, or sorry, partner replacement there. Okay, now we've identified the reaction type as single replacement. Right? We predicted the products, potassium nitrate and aluminum metal. Right? We wrote correct formulas based on the charges. Last step is to go back and balance. So over here I've got 1 potassium, 1 aluminum, and 3 nitrates. On this side I've got 1 potassium, 1 aluminum, and 1 nitrate, which means I need go back and balance this bad boy. So when balancing, I'm going to put because I have 3 nitrates here, that means I need to put 3 over here. But remember, I can't put the 3 as a subscript. It needs to be a coefficient, which is going to now turn this into a 3 and this into a 3. Okay, so that balanced out my nitrates. Now my potassium's out of balance, but I can fix that with another coefficient 3 there. Done. All right, moving on to the next one, we have aqueous sodium nitrate. So this is Na plus nitrate, NO3 minus, and aqueous potassium iodide, so K plus I minus. Now this should be an easy one to write. They're all 1s, so we just stick them together. NaNO3 plus potassium iodide. Right? That is clearly an AB plus CD double replacement reaction. All right. Now, when we predict our products with a double replacement, right, the cations just swap places. So the sodium and the potassium are simply going to swap places. And again, this should be really easy because they're all 1, so it's just going to be KNO3 plus NaI. Okay? Now, some of you, if you took some more advanced chemistry, you might recognize that all of these would end up aqueous, and there actually wouldn't be a reaction here. But for the sake of this and my students this year, right, we'll just predict that a reaction does occur, and it looks just like this. And everything is already balanced. There's one of everything, so that's a piece of cake. All right, two more. Next one, we got aqueous sodium carbonate. So this is Na plus and CO3 2 minus, and aqueous iron 2 chloride. So this is Fe2 plus and Cl minus. So we're going to combine those. So it's going to have to be Na2CO3, right? I had to add that 2 subscript because carbonate's a -2. So we need 2 sodiums and just 1 carbonate plus iron 2 chloride. So this is going to be FeCl2. All right. Now that will yield, all right, certain products, and we're going to predict those products based on the type of reaction it is, which is double replacement, which again just simply means my cations, my sodium and iron, are going to swap partners here. All right, so I'm going to form iron carbonate, and they're both 2, so iron's a +2, carbonate's a -2, so we're just going to put those formulas together with no additional subscripts added, other than the 3 that's already part of the carbonate. And sodium's a +1, chloride's a -1, so it's just going to be NaCl. Okay, now this one does not appear to be balanced, so we've got 2 sodiums here, 1 carbonate, 1 iron, and 2 chlorines. Over here I've got 1 iron, 1 sodium, 1 carbonate, and 1 chloride. Okay, so my sodiums and chlorines are out of balance. This looks like a pretty easy thing to balance. I got 2 sodiums, 1 sodium, so I'm going to add a subscript of a 2 here, which fixes my sodium to 2 and my chlorine to 2, and looks like we're balanced. Okay, last one. We got rubidium hydroxide. Rubidium is a +1, hydroxide is OH, and it's a -1. Then we got hydroiodic acid, and because I didn't teach you guys acids, I gave you that little formula. So it's going to be RbOH, okay, plus HCl. This looks like another double replacement to me. Okay, or an acid-base reaction, if you will. Okay, so the rubidium and hydrogen will essentially swap places. So we're going to form HOH plus RbCl, and it looks like it is all nicely balanced already. So nothing additional to add there because I got 1 rubidium, 1 hydroxide, 1 hydroxide, 1 hydrogen, 1 hydrogen, 1 chlorine, 1 chlorine. Done.